Okay, this is 3.3. We're going to start with reviewing how to solve a system by graphing, then we're going to learn the second of the three methods. So negative 3x minus y equals negative 2, 4y equals negative 12x minus 12. Okay, so I'm going to make a table. Negative 3x minus y equals negative 2. 4y equals negative 12x minus 12. Okay, so y is over here, but it's not isolated. It's not even close. So first I apply the coefficient of 1, but it's negative 1. I hate negative coefficients on y's. So plus, plus, plus. Okay, they're all negatives, so they switch. Then we minus 3x, create a 0x and minus 3x from there. Okay, so line up your equals, you got 1y. 0 minus 3 is negative 3x, and then plus a 2. You can divide by 1, or if it's a 1, you can just take it off, because it's all going to be the same. So slope, y-intercept. Okay. So our slope is negative 3, the y-intercept's plus 2. Now let's come over, look at this. Is y isolated on that side? It's close, but not quite. Okay. At least it's a positive 4, so we don't have to change signs. We're just going to go divide by 4, then the y is free at last. Negative 12 divided by 4 is negative 3x. Negative 12 divided by 4 is minus 3. Okay? So MB. So the slope is negative 3. The y-intercept is minus 3. So now I'm good to graph. Plus 2. Then every time I go down 3, I got to go 1 forward. Okay, then I take my ruler and graph it. There's first line. There's second line. You're going to start at minus 3, 1, 2, 3. But the slope's the same. So for every time I go forward 1, I go down 3. I believe those are going to be parallel, okay? They ought to be because they have the same slope, okay? Anytime they have the same slope, we're going to have parallel lines. Okay, so no solution, NS. Okay, next problem. We're going to have y equals negative 1/2 x plus 2, and then y equals positive 1/2 x plus 6. Okay, y equals negative 1/2 x plus 2, y equals 1/2 x plus 6. Okay, I think the y is isolated in both these bad boys, so I have my m and b right off the bat. Don't have to rearrange anything. So the slope, negative 1/2, plus 2 is the y-intercept. Slope, 1/2. Plus 6 is the y-intercept. So every time I go forward 2, I go down 1. So down 1, forward 2, down 1, forward 2. Okay, then the second one, plus 6, 1, 2, 3, 4, 5, 6. And that's going to be up 1, forward 2. Okay, so there's one solution because they cross, and they cross at 1, 2, 3, 4. Negative 4 is my x, and then positive 4 is my y. Okay, and then the last graph, then we'll get on to the new thing. 2y minus x equals 2, y equals 1/2 x plus 1. So 2y minus x equals 2, y equals 1/2 x plus 1. Okay, y is not by itself. Here's the y with a 2. It's positive, but I do have to move that minus 1x out of here. Plus 0x and add 1x to 0x. Okay, so line up your equation. You got 2y. 0 plus 1 is 1x plus 2. Okay, so y equals 1/2 x plus 1. And now I know my m and my b. Here the m and the b is already set. Look at these. I'll graph one of them, but I can't graph them both because it's just the same line, okay? Slope's a half, plus 1's a y-intercept. So I will be going forward 2 up 1. And this is going to be an IMS, infinitely many solutions, because these are the same equation, they're just written differently. Alright, now let's do some a new thing here today. And those of you at home, you're going to take your notebook paper, split it into Hermsen's 8 boxes of doom, okay? We're going to use 4 boxes to do each problem. This is called solve by substitution. So we have 2x plus 2y equals 38, and then we have y equals x plus 3. Okay, I'm going to solve this without graphing it, and this is a system. So graphing's one way, substitution's the second way. Now, what you're going to do is you got to find a variable. It could be x or it could be y. It doesn't have to be y, okay? Either x or y, and one of the two equations that's isolated, okay, by itself. Well, here nothing's isolated, but here the y is isolated. So I'm going to box up the y, and I'm going to circle the expression that the y is equal to. That's known as your base equation. When you're solving by substitution, you need to have a base equation where one of the letters x or y is isolated. This is known as the off-base equation, so I bring it over here. What's the letter you got by itself? Y. Please parenthesize the y, cross out the y, then above the parentheses put what y is equal to, which is x plus 3. So create your new equation. You have 2x plus 2, parentheses x plus 3 equals 38. Now I can solve for x. I need to apply the distributive property from the 2, not the 2x, okay? You can drop down the 2x or add it at the end, but the distribution happens here. So 2x, then 2 times x is another 2x. 2 times 3 is 6. Now your x's are on the same side, so you're just going to combine those. So that's going to be 4x plus 6 equals 38. Then I just subtract 6. 4x equals 32. Divide by 4. X equals 8. So 8. Now here's how we're going to solve for y. I would probably use the equation where the y is by itself. I mean, if I have to figure out y, why not use the one where y is by itself? Because we have our answer for x, it's 8. So y equals 8 plus 3. Well, I guess y equals 11 then. So 8, 11. Okay, next problem. X. We did this a lot in Algebra 1. Everybody fresh, juniors, sophomores, all those, okay? Find a letter isolated. It doesn't have to be the y. X will work just fine, okay? That's the base equation. Now write your off-base equation. 3x plus 4y equals 7. Now the x is the letter by itself, so this time we'll be parenthesizing the x, removing it, and putting in the expression y minus 3, okay? So we have 3 times the expression y minus 3, and then after the parentheses ends, we have plus 4y equals 7. Okay, so I applied distributive here, 3y minus 9, or plus negative 9, I don't care how you want to do it, but remember to add your 4y homes, okay? Okay, the y's are on the same side, so you need to combine them. That'll be 7y minus 9 equals 16, equals 7. Then you minus 9. 7y then is equal to 16. Then divide by 7. Now, 16 divided by 7 is a decimal. When that happens, you go second, PRB equals, and then 2 2/7. So y equals 2 2/7. We kind of want exact answers here. Now, again, we're solving for x. Use the one where the x is by itself. So x equals y minus 3, okay? Because I have the answer for y. It's 2 2/7. So I have x equals 2 2/7 minus 3, which is going to be negative 5/7. Use your calculator, okay? And that's the solution. See, I would never know that on a graph because it didn't come out that the solutions aren't integers. That's a beauty. You need kind of a other method besides graphing, okay? Negative 2x plus y equals 3. 3x minus 2y equals 5. You got a little problem here to apply substitution. You don't have an isolated variable. Okay, so let's find the next best thing. What variable doesn't have a multiplier? Probably this y right here, okay? So I could just add 2x, create a 0x, and add 2x to that. Now I have, I'll go down here, I'll just go above it somewhere, okay? Y equals 2x plus 3. Then forget about the original. That'll work as the base, okay? So there's my base. So you can rewrite one of the equations, but don't torture yourself. See, right there, that's a lot more work to get one of the letters by itself than it is here, because I know I won't have to divide. I just add the 2x. Okay, write the off base, 3x minus 2y equals 5. So y is the base variable. Parenthesize it, cross it out, put 2x plus 3. Now we have x and x, okay? So 3x minus 2, then parentheses 2x plus 3 equals 5. We distribute from the 2, not the 3, okay? The 2's plus negative, so you distribute that. It's a negative 2 you're distributing. So you can drop your 3x or add it at the end, I don't care, but when you come to the negative 2, that's when you start multiplying. Negative 2 times 2x is negative 4x, negative 2 times 3 is negative 6. Okay, combine your x's. 3 plus negative 4 is negative 1x, plus negative 6 equals 5. Okay, then get rid of your negative 6. You'd add 6 to 5. That would be 11. Then we'll divide by the negative 1, and x equals negative 11. Now I have to solve for y, so let's use the base because that's the one that's got the y by itself. So y equals 2, x plus 3. We'll put the negative 11 in for x, we know that, okay? So y equals 2 times negative 11 plus 3. Okay, so I'd times those, that'd be negative 22. Negative 22 plus 3 is negative 19, okay? So there's the solution. Okay, next up, x equals negative 2y plus 14. 4x plus 8y equals 16. Okay, you got a letter by itself? Yes, you do. Okay, so you already have your base equation. You don't have to rewrite it. Okay, write the off base equation. The 4x plus 8y equals 16. Now that letter that's by itself, I parenthesize x, cross it out, and in its place I put negative 2y plus 14. This is why it's called substitution. We're substituting the x variable with its equal. So 4 parentheses negative 2y plus 14. Now after the parentheses you have the plus 8y. A lot of people forget that y out after that. They'll just put equals 16 and skip the plus 8y. Don't do that. Okay, 4 times negative 2y is negative 8y. 4 times 14 is 56. And then plus our 8y equals 16. Okay, what happens here? Negative 8 plus 8 is 0. Don't write y. 0 times y is 0. Okay, so don't write y. Writing a y tells me that that's 1y. It's not. Okay, so basically you can cross these out. If they add to 0, forget it. And we have 56 equals 16. That's a no solution. Okay, so NS. So if I graph these lines, they'd be parallel. Okay, next problem. 4x plus y equals 2. 3y plus 2x equals negative 1. You don't have a letter by itself, but what's a letter that isn't being multiplied? Probably this y right here, okay? Now I'll just move the 4x out of here by subtracting, create a 0x. And now y is by itself. 0 minus 4 is negative 4x plus the 2. Beautiful. Now I have my base equation that I need to use in substitution. The off base is 3y. Keep your y comes first for some reason in this one. So I parenthesize the y, cross it out, and I replace it with negative 4x plus 2. Okay. So you have negative 3. Instead of y, we have negative 4x plus 2 now. And then after the parentheses, you have to add 2x and then equals negative 1. So I apply the distributive property from right there. Negative 3 times negative 4 is 12x. Negative 3 times 2 is negative 6. Then I add the 2x and I'm equal to negative 1. Okay, adding those because they're on the same side is 14x plus negative 6 equals negative 1. Then I add 6 to both sides. That's 5. 14x equals 5. Divide by 14. That's a decimal. Then ABC it back with the PRB button. See, don't want that. Second PRB equals, it would just remain 5. So x would be 5/14. Now if you're solving for y, use the base, because I mean you could use that, but it's a lot more work. See, if I use a base, the y is already by itself, because the y is what I have to find. So I parenthesize x and put in 5/14. So y equals negative 4 times 5/14 plus 2. Okay, we times first. Negative 4 times 5/14. I'm going to show you that I'm proficient with fractions, okay, along with some of you. I'm going to do it in my head first, okay. It's going to be negative, I'm guessing it's going to come out negative 1 3/7. Bam, okay. Plus 2. Then I'm going to add those to prove to some of you I am proficient with fractions. Before I hit equals, I'm going to try to do it in my head. Okay, it's 4/7. Okay. Okay, there you go. All right, and then the last one. X equals negative 2y plus 4, and then 7x plus 14y equals 28. Okay, we already have our base set because that x is isolated. Remember, it doesn't have to be the y. Okay, it has to be the y on a graphing problem. We're not graphing. Substitution can be x or y. Okay, parenthesize your x, your base. Okay, negative 2y plus 4. So 7 parentheses negative 2y plus 4 plus 14y equals 28. So I apply the distributive property. That's going to give me negative 14y plus 28 plus 14y equals 28. Funny thing happens here. Negative 14 plus 14, 0. Don't write y when that happens. When it's 0, you need to just get rid of all the variables, okay? 28 equals 28, I think it is, so this is an IMS, okay? That means these equations are exactly the same, they're just written different. Okay, on the assignment you got 3 graphs, then 4 problems where you're going to apply substitution. Number 6, don't get freaked out. We can easily make that the first equation a base if I just subtract 2x from that side and from that side, obviously after I think of a 0x.